This building is the size of 50 football fields, completely covered in solar panels generating clean energy. Inside this massive structure, a manufacturing revolution unfolds every second through synchronized robotic dance. This powers tomorrow's electric vehicles, but the journey begins with something much smaller and simpler. The lithium-ion battery cell appears simple externally, but contains incredible internal complexity and precision. Today, we reveal the complete 14-stage manufacturing process that transforms raw materials into power. From raw chemical dust to high-voltage energy packs, welcome inside the world's most advanced Gigafactory. Step 1 begins with the essential ingredients, colorful powders that form the battery's chemical foundation. Nickel, cobalt, manganese, and lithium flow through massive pipes directly into the factory's mixing systems. The mixing phase creates what we call slurry, a thick battery batter that will become the electrode coating. Solvents ensure perfect viscosity while eliminating air bubbles that could compromise battery performance. The slurry requires a conductive backbone, beginning with copper foil thinner than human hair for the anode. For the cathode, aluminum foil provides the conductive substrate, both materials handling immense currents. The coater applies slurry with micron-level precision, determining the battery's ultimate energy density. Coating thickness is critical. Too thick causes overheating. Too thin yields insufficient energy storage. The coated foil enters a 100-meter drying oven where solvents evaporate under precise temperature control. Heat creates permanent chemical bonds, while sophisticated systems recover and recycle evaporated solvents. Emerging dry and stable from the oven, these coated metal foils now officially qualify as electrodes. Beta ray scanners inspect every square millimeter, demanding absolute perfection before advancing forward. To maximize energy capacity, identical coating is simultaneously applied to both sides of each foil. Accumulator towers maintain continuous production flow even during material roll changes and maintenance. The coating line represents the factory's largest single machine, stretching hundreds of meters continuously. Operators monitor real-time data, ensuring optimal density and loading levels throughout production. The air here maintains 100 times greater cleanliness than standard hospital operating rooms. Automated guided vehicles transport giant electrode rolls to the next critical phase, calendaring. Calendaring is essentially industrial-scale compression, applying massive pressure to electrode materials. 20 tons of pressure compresses active material, dramatically increasing overall energy density. 40% thickness reduction creates mirror-smooth surfaces essential for optimal battery performance. The slitter machine uses razor-sharp circular blades to cut wide master rolls into narrow strips. Each precisely cut strip will eventually become one complete battery cell after additional processing. Vacuum systems immediately capture microscopic debris, preventing potential short circuits later. Narrow strips wind onto smaller spools called pancakes, now ready for cell assembly. Laser notching creates precisely shaped tabs that will connect individual cells into larger systems. Vacuum oven baking eliminates remaining moisture, as water is fundamentally incompatible with lithium. Water contacting lithium causes dangerous degradation, so we bake cells to near zero moisture levels. Robotic systems now assume primary material handling, minimizing human contact with battery components. Now we unite the positive cathode and negative anode, separated by a critical insulating layer. This white separator film prevents direct contact between electrodes while permitting ion passage. The separator maintains electrical isolation, preventing short circuits and potential thermal events. 3 precision-aligned rolls prepare for what becomes the manufacturing process's most hypnotic phase. The winding machine begins creating the jelly roll, spinning multiple layers into perfect alignment. At speeds exceeding visual perception, the machine winds electrode and separator materials perfectly. Each completed roll receives automatic cutting, taping, and ejection, producing continuous cell cores. Thousands of jelly rolls progress hourly along conveyor systems towards subsequent assembly stations. High-potential electrical testing verifies separator integrity, ensuring no damage induced by winding. Nickel-plated steel cans arrive, providing protective housings for delicate internal jelly rolls. Mechanical arms precisely insert each jelly roll into its protective metallic armor. Welding connects the negative electrode tab directly to the steel can's interior bottom surface. Rotating grooving tools create precisely positioned seats for subsequent top cap placement. Cells move into electrolyte filling chambers, where battery chemistry becomes fully activated. We inject electrolyte solution, the magical conductive liquid enabling ion movement between electrodes. The jelly roll acts like a sponge, absorbing electrolyte through capillary action into every microscopic pore. Laser welding hermetically seals the cell, creating an airtight environment that maintains chemical stability. A thorough wash removes any external electrolyte residue, ensuring clean electrical contact surfaces. Each cell receives a unique QR code for lifetime tracking, enabling complete manufacturing history access. Despite their finished appearance, these cells remain completely discharged, holding 0 volts currently. Formation towers represent the battery's birthplace, where each cell experiences its initial charge cycle. Robotic systems handle 50 cells simultaneously, inserting them into specialized charging trays automatically. The first charge creates the solid electrolyte interface, a critical protective chemical layer inside. Thermal monitoring ensures safe temperature profiles during this crucial chemical stabilization phase. Initial charging releases gases, which we safely vent and then reseal cells to maintain perfect integrity. The aging warehouse provides weeks of monitoring, ensuring long-term stability before battery deployment. Cells rest for extended periods, with automated systems detecting any abnormal self-discharge patterns. Automated cranes retrieve battery pallets, rejecting any cells displaying unacceptable voltage declines. Final voltage verification occurs through rapid automated testing, ensuring only optimal cells advance. Precision grading sorts cells by exact capacity, ensuring perfectly matched performance in final packs. Individual cells receive protective packaging for transportation to module assembly stations nearby. We transition from individual cell production to the powerful pack assembly manufacturing line. The pack assembly floor features larger scale robotics handling thousands of cells simultaneously. Cells receive precise alignment within specialized plastic holders that maintain proper positioning. Thermal interface glue provides both mechanical adhesion and essential heat transfer capabilities. Robots stack cell layers into modules, each containing approximately 400 individual cells. Copper bus bars connect all positive and negative terminals, creating parallel and series connections. Laser welding simultaneously connects 400 cell terminals in less than 1 second precisely. Weld inspection reveals intricate copper and aluminum patterns that represent functional artistry. The battery management system serves as the pack's intelligent brain, monitoring every parameter. High-voltage orange cables connect modules, with the BMS ensuring balanced operation and safety. The pack case forms the electric vehicle's structural floor, providing both protection and rigidity. Heavy robotic arms lower multiple modules into the pack case with millimeter-level precision. Cooling system plumbing connects between modules, creating continuous liquid temperature control. High-voltage bus connections link modules, creating either 400 or 800-volt architectures. Fire-resistant barriers provide additional safety layers, preventing potential thermal propagation. A continuous sealant bead ensures complete waterproofing, protecting electronics from moisture. 20 automated drills simultaneously secure the top cover, completing the 1,000-pound assembly. Leak testing verifies waterproof integrity, ensuring survival through extreme weather conditions. Final electrical testing confirms all systems operational, bringing the battery pack fully online. Automated labeling applies high-voltage warnings and specifications, completing pack preparation. The marriage process unites the battery pack and vehicle chassis, creating a complete electric vehicle. The pack lifts and bolts into the vehicle's underside, becoming an integral structural component. The complete vehicle lowers onto its wheels, now powered by its newly installed energy source. At the production line's end, automated charging begins the battery's operational life cycle. The vehicle's display confirms full system functionality with a 100% charge status. Dynamometer testing verifies smooth power delivery and performance under simulated road conditions. Water spray testing confirms cabin and battery compartment integrity against potential water ingress. Recycling begins the circular journey, with old batteries processed into valuable raw materials. 95% of battery materials can be recovered and reused in new battery production. A sustainable circular economy emerges, powered by renewable energy and material recycling. From raw mineral dust to elegant transportation, the complete manufacturing journey concludes. The driver experiences silent electric propulsion, representing manufacturing's transformative future. Thousands of dedicated people and advanced robotic systems collaborate to create this technology. 14 precise manufacturing stages transform basic materials into advanced energy storage. Share your favorite manufacturing stage in comments below and suggest our next factory visit. We appreciate our supporters who make these deep explorations of modern manufacturing possible. Explore related manufacturing processes through our additional factory documentary content.